It's time! Welcome to the match, to the last session of the day, of the DevOps day. We'll have a super session in heavyweight signature category for Maven Central. On the left, we'll have the current champion, PGP, the good old standard that is there for 20 years. On the right, we have the new joiner, Sigstore, which is promising to win absolutely everything in the next 20 years. Let's see who will win. I will be your referee today, so I am Hervé Boutemy. On my day, I'm working as a solutions architect at Sonotype, a company that works on software supply chain, open source components, and that is managing Maven Central repository. So I work with a team who manage Maven Central repository. And on my nights and weekends, I am a Maven developer, I am a Maven maintainer, I am an Apache Software Foundation member, and I worked on many aspects for the last 17 years about Maven, and currently I'm working for the last years on reproducible builds and on Sigstore integration, both from a Maven point of view and helping to deploy it for Maven Central. I won't be able to do it during the whole, the whole session. Let's start with a poll to see where you are on signatures. So let's see. Who is a Java developer in the session? OK, everybody, perfect. You are the right target. Who did ever publish to Maven Central? Half of the audience. I fear there is a bias, because in general, less than 10% is really publishing to Maven Central, because only open source providers publish to Maven Central. But perfect, I have the good population. And for you, who had a good experience when signing PGP? Oh, one. And two so-so. Yeah. There is just more publisher than usual, but it's the feedback we get. Who downloads, on the opposite, who downloads from Maven Central? Everybody, of course. But who tried to check PGP signatures? Oh, 3 people. It's much more than usual, even if it's only 3. And what was your experience when checking? Was it good? For nobody, oh, it was good. Oh. We have only one guy who is happy with verifying GPG signatures. So it is the key problem we have. We talk about signatures. Everybody wants to sign, perfect. But nobody checks the signature. So let's start. Why are we talking about signature? Why is it important currently? We are in a world where we assemble a lot of components coming from everywhere. In every ecosystem, Java, NPM, Nugget, we consume a lot of components coming from everywhere. And the number of components we ingest have such a high load, high volume in our production applications that they become a vector of attack for hackers. Until a few years ago, hackers were waiting for vulnerabilities. They were just standing, waiting for a vulnerable component to be found, and then they started to attack companies that did not upgrade. So it lets us some time to fix the issues. But in fact, waiting for something to happen, it's not proactive. Hackers are professionals now. They need to be proactive. Why wait for a vulnerability to be found? No, it's much better to inject your malicious code directly and trick people to download your artifact where you put your own malwares to inject in the application without even waiting for any vulnerability to be found. It is what is currently happening since a few years that is really increasing in an incredible rate. And the principle for hackers to know inject malware in the supply chain is quite basic. We have projects, we have open source projects providing releases of their project. We have developers who want to get the open source component, and we have hackers who want to use the link, the fact that the developer doesn't know the project very well, to inject his malware. So when the project publish new releases, they publish it somewhere in Maven Central, in their own public space, and developer expects to download the right artifact from the project. It is the expectation. He writes in his build tool what are the coordinates, and he hopes that everything is downloaded straightforward. The change is quite easy. You know, I download, everything is easy. Developers don't really get how the line between the open source project and his laptop is not so straight. It's much more fuzzy. There are mirrors. There are other repositories than Maven Central. There are a lot of places where, in fact, hackers are really, oh, that fuzzy, that noise in the middle is perfect to try to hide, to hide a bad component, a malicious component. If I could trick the developer to use my component instead of the expected official component, it would be nice, because the developer who thinks he gets the right one has my malicious one. This is what attacks on supply chain do. It is what happens every day, and this is what signatures want to fix, want to avoid. And the principle for that is that the public project has an identity. We know the public project. It has a key. It has something that proves that it is the official project. And on each release that he will do, he will sign the artifacts to really have a digital signatures associated to every component. So when the developers download the artifact, he can download also the signature and check that the signature is a signature that corresponds both to the artifacts and the project he was expected to download from. And this is how, if a hacker hides a bad component, hides a malicious component, the developer and sadly, he managed to get it in the supply chain. When checking the signature, the official signature, the developer will detect that the component is not a component that was signed by the official project. So he knows that he must not run it, he must not use it. Eventually, the hacker has himself an identity, which is of course different than the identity of the project managers. He could sign his artifact, but why, if the developer downloads the bad component and downloads the right signature for the bad component, but right means the signature that is visibly done by the hacker and not by the project, why would the developer, when he checks, accept from the hacker instead of accepting the component from the project? So this is how we protect against hackers injecting malwares into supply chains. The key aspect that everybody forgets about, it works only if you check signatures. If nobody checks signatures, it's not useful to sign, because we can all sign, and if everybody just forgets about checking, the hackers will just provide the bad component, and it works. And this is why we have signatures on Maven Central for years with PGP. So let's have a look. Why are we talking about changing PGP? Why are we talking about not using what we have for 20 years? It works. So let's have a first look at PGP. So PGP, developers are not cryptography experts, so let's be very basic. PGP, pretty good privacy. So it started in 1991 with one guy who created PGP. So he created it. He created a company to maintain it. He in fact created cryptography for public people. And given it was the first time public cryptography was provided to everybody, to be able to distribute it, he had to make on his proprietary software, he had to make the algorithm public. And this is how PGP became the de facto standard for people who wanted to have digital signature or encryption. Of course, having public algorithm on a proprietary implementation, the next step has been done near the 20th century. In fact, from the public algorithm, he went to do a standard, Open PGP standard, which is the official way to define how PGP was working, but for implementation from absolutely everybody. And one key implementation is the open source implementation from the Free Software Foundation, which is GNU PG. So it is GNU Privacy Guard, and it is the first stupid issue that anybody working with PGP has when starting to understand. You talk to me about PGP, then what I use on command line is GPG. Is it the same thing? Is it something different? Yes, GPG is the main implementation of PGP. Whoa, user experience starts very well. Yeah, it's awesome. The principle of PGP is based on on asymmetric cryptography. So you have a keeper, you create a keeper where you have a private key that you keep private, and then you publish a public key for everybody's consumption. And based on this keeper, there are two use cases. Either you want to crypt something and and only the owner of the private key can decrypt it. So you use the public key that everybody has, and only the private key owner will be able to decrypt. It's not our use case. The other use case, which is the use case we want to dive in today, is digital signature. This case, we use the private keys, the people who are officially owning the private key can sign the content, Then anybody getting the public key can check the signatures against the content and be sure that the content was the content that was signed by the owner of the content. In our case, it is the project, the binary we are trying to download. And PGP is the de facto standard since that time. It is a de facto standard for everybody doing encryption or signature. So this is why we deployed it at Maven Central. In fact, before even deploying it at Maven Central level, PGP was deployed at Apache Software Foundation level. So in 22, given Apache Software Foundation had distributed open source code through mirrors, through a lot of ways. So because bandwidth at that time was not so easy to get. So there were a lot of universities mirroring content. And it is exactly the type of injections that could be possible. Someone could mirror the official site and just change one thing in the middle. So this is why Apache Software Foundation enforced since 22 that every source code release that is published since that time is PGP signed. You have no choice. It is PGP signed. It is part of the Apache Software Foundation governance. Then, each time you download from public mirror a binary from Apache Software Foundation, in fact, we urge you, we have instruction to download the signature and check the signature. So it's not by inadvertence that on every Apache project, when you go to the download section, oh, sorry, I have to switch. Yeah, it's okay. Okay. So each time you get to an Apache project and you go to the download section, the fact that on everything, every archive you can download, we provide checksum for basic direct check, but we provide also signatures, which are PGP signatures. And we provide some instruction. We highly recommend to check the signature. Nobody does it. It's your problem. But we highly recommend to check the signature, and we explain how to check it, how to use GPG to verify the signature, to discover that you don't know the key. So, good news. At Apache Software Foundation, in the governance, we have each project has a keys file that defines which keys are allowed to publish that project. So we can get the keys, and then we can really check that every binary that is, every archive that is provided by Apache Software Foundation is the real one provided by the right people. So this is what Apache Software Foundation does for years. So when Apache Maven project created Maven Central, it was created for Maven 1. So it was created very early, even before the PGP signature was enforced at Apache Software Foundation level. So that's why the repository that was created at that time, which is the repository that is nowadays defunct, the repo1.maven.org/maven, there was no signature supported. Okay. Then we created Maven 2. And for Maven 2, we created a new repository because we wanted to improve the format. We wanted to have the famous reverse DNS group ID that is transformed into directories. We wanted to have the famous the POM v4 object bundle to download, to define dependencies, and so on. Then we stopped maintaining the Maven 1, the Maven Central 1 repository. We created Maven Central repository as it is known now, and now you understand why it is written in the repository URL. It is written Maven 2. And on top of that, we added to Maven and Central repository, we added support for PGP, so publication of these signature files. And not only we support it, but we force everybody wanting to publish to Maven Central to provide exactly the same type of signature that we provide, that Apache Software Foundation expects from Apache projects. So this is why, since 2006, every artifact that you find from Maven Central has a signature. Nobody checks, but it is available. Artifacts before that time don't have signature because at that time we did not enforce it. And from the experience of running that for now 20 years, we found the shortcomings with PGP, because honestly, keys management is just quite complex for users. The first time you need to read the documentation to create your key, it's something. Then you put your key somewhere, your private key, because the private key is very important, and then you lose it. What do you do? Then you are traveling. Oh, I did not copy my key from my primary computer to the second one. Oh, I can do a release because I don't have my private key currently. I will have to wait to come back home. Oh, what happens if your key is stolen? So managing key is not only the initial creation. You have to imagine about rotating key, because my key from 10 years ago, is it still valid given algorithms have changed? So, oh, I need to learn one more thing about cryptographic algorithm. No, sorry. It's not possible. It's a pain to sign. Signing with PGP is really a pain, and this is exactly what happens when I poll at the beginning of the talk. It's not fun. But imagine, signing is not the most important thing. What is important is to check what is the equivalent to the Apache Software Foundation keys file. You know, where the project says which keys are allowed to publish something for Maven, for HTTPD, for any Apache project. You don't have it. And the weird thing is that if you look at the instructions to verify signatures, you have an email. Do not trust the email. It is not checked. So if I want, I create just now a key with superman@devox.be. I don't own this email, but I can create a key. It is a public key, and it will be my key. So the only way to know a key is to have its hexadecimal ID. You know, the thing that is. At that time, it was said as a nice thing, because you could put it on your card and give your key to people around you. Who does this? Does this know? It has been thought in the past century. There is a notion of a key signing party with Web of Trust, something that was expected to be fun. Who ever went to a key signing party? Was it fun? No. yeah. So key signing party, we don't do it. So the model of trust of PGP did not scale. So checking is even worse a pain than signing. Imagine you didn't like sign, you didn't check. It's even much more a pain to check signatures. This is yes, your question.
If the valid keys are in a file in the project, why do we need the Web of Trust in this case?
In this, so the question is, if people distribute the official keys lists in their GitHub repository or in a separate place, why is the Web of Trust necessary? It is not, in fact. It is another way, because, in fact, in fact, we tried multiple models. The model of keys file, the model of Web of Trust, and none of them really matched the size of the community and the growth of community. And this is exactly why Sigstore wants to push people to sign and check signatures. And sorry, it won't be possible with PGP. We need to do something that has a better user experience. So that's why Sigstore promise is to have a nice, easy keyless signature experience, both for signing and checking signatures. So it is quite a new project. It was only created in 2020. But it is quite successful. So it was donated to the Linux Foundation and is nowadays managed under Open Source Security Software Foundation, with multiple companies backing the efforts. And the first release of something usable from Sigstore was released 1 year ago. It was Cosine. Maybe you have already used Cosine. So it was the first release to sign and verify signatures. Not yet a keyless version. So it is classical keys, but it was the first release. And the work on keyless workflows, keyless way of doing, is a work in progress that is currently happening, that I will explain where we are at the moment. But the objective, the idea is really that what is done should be used by every repository in the world, Maven Central, but also npm.js, PyPI, and so on, and be used by every build tool that push or consume from this repository. So there is a huge work done with many communities to not only build Sigstore, but make integration and work with every communities to use that. And so Sigstore becomes a de facto standard, not only for Maven Central, but for every ecosystems. So I will have a light overview of how it works, because concretely, how does it work? So for keyless signatures, it all starts with command line tools, with Cosine. There is a new tool that was added, which is GitSign. So you have it's open source, so it's written in Go. You can use it. Okay, the command line tools are available, perfect. You have some libraries, you have some documentation, because if you want to work, everything natively is written in Go. If you want to work in Java, you will need a Java library, in Python, a Python library, and so on. And for the keyless aspect that is being worked on, you'll need server software to manage the keys, to manage all the hard thing that has to be done for the keyless aspect. And there are two main parts. The first one is Fulcio. It is a certificate authority that will provide short-lived certificates that will attest the identity of the signers. And for that identity, it will use normal standards from nowadays, OpenID Connect. And then once the certificate is done, every signatures will be registered, will be recorded in Sigstore record that will store every signature, and in a non-modifiable way. It is append only. It will have to be checked by all the community to be sure that what was signed is really something that is not tricked in the future. And so all that is software. You can download it, you can install it home, you can deploy your own Fulcio or Record servers. Then you will have your whole Sigstore infrastructure. And the unexpected, the unusual aspect in addition to this software is that Sigstore also works on providing one public service, one public instance of Fulcio and Record for open source projects. Instead of every open source project, every open source foundation to create their own Record and Fulcio instance, we will try to create a common one, a common instance that will be community managed by multiple actors from open source that will manage together the trust Record and the trusted Fulcio instance for every open source ecosystems. So people will be able to, if they are in private situations, they can host everything from themselves without discussing. It is open source. You can do it yourself. But for open source, you can use the public instance. And the workflow, because everything is about, I talked about a little bit about architecture. The key thing is about what is the experience to do that. So what is the workflow to sign? It all starts by generating locally a session keeper that will be thrown away after the signing session. So it's just temporary keeper. And you can sign the files that you want. So you sign everything that you want to be signed during the Sigstore session. Then starts the keyless aspect that will record, that will check, that will prove that the signature has been done by someone who is the trusted people we expect to have done the signature. And this is where Fulcio enters in the loop. You contact Fulcio to ask for a short-lived certificate, and Fulcio asks an OpenID Connect identity provider to know who you are, because everything is about identity. So let's use a normal standard that everybody use for email, OpenID Connect. And Fulcio use that identity to create a short-lived certificate. A few months ago, when I prepared the presentation, it was 20 minutes short-lived. The guys here changed to 10 minutes. I don't know when. So short meant 20 minutes a few months ago. No, short is 10 minutes. Okay, I don't care. It's the same. So you have that certificate that will attest the identity of the signer for 10 minutes now. And then you will use Record to register the different signatures you did. And Record just proves that you signed with the private key that was valid and the certificate that was valid for only that 10 minutes. So the certificate, the key pair you generated in 10 minutes, even if you did not throw it, someone got it on your computer, in 10 minutes it's over. It's not usable anymore because the certificate won't accept, Record won't accept a certificate for a signature done with this private key pair after the famous 10 minutes of certificate time span. No? Let's demo it. Yes. So I did a small project, a small Java project that will just sign a file with a basic command line tool with only Java code. And that Java code will show precisely each step of the workflow I just showed. It creates first a key pair. Locally, it creates a key pair with JavaX security components, and that we get a key pair, private key, public key, perfect. Then, with local crypto code, we can sign the file, and then we have the signature of the file. Okay, that's the first step of the workflow. It will be in your tool. It will create that. Okay, perfect. Then we start the keyless workflow by calling the OpenID Connect client to do the authentication. So this is, well, of course, I have no luck. No, it works. Yes, when we launch the OpenID Connect session, it proposes you the different OpenID IDP that are supported by the public. So I'm using the public instance. So currently there is a GitHub IDP, Google IDP, and Microsoft one. So if I log in with my Google account, I have multiple accounts. So I choose my identity. Yes, I have 3 identities. Yes. So I chose to sign with mine. And when the identification, the authentication has been done, my program gets a proof that, so it gets my identity my email that I just defined in my browser. Then we can use Fulkio to sign to prove that we own the private key. And this is the authentication that is done with Fulkio to get the Fulkio certificate. Then we get the certificate, and it is, yes, certificate, binary certificate. We can use it now to record the signatures we did in the beginning. So we'll call the record with the content of our signature. So we define the record that we have to do, the hash of the file that we signed, and the signature that was done previously with the certificates that we got. And in return, Sigstore sends us a proof of signature that we will be able as a proof that we signed during the famous 10 minutes. So the proof of signature is available directly from Record server. So you can see the binary content. Of course, the binary content is not very funny. So that's why nice people from the project created a UI where you have that data perfectly decoded and perfectly understandable. And then you see that my certificate and my record was done by Sigstore. It was valid. It was valid only for 10 minutes. So in theory, I could still use my certificate for 9 minutes because I just did it. I see the algorithm. I see that I did it with my email as controlled by Google. So I have every data. It is stored in Record. It is available. And this is the signature that people will be able to check later when they will check the signature against the artifact that I just signed. This is the signing experience. Yes, question? So the question is that one? So what is the extension here? I don't know. I am not a Sigstore expert on the level of detail. Apu here, I don't know. Yes, they are the expert implementing the tricky details that I don't know.
Certificate transparency. It's an entry into the certificate transparency. Okay. It matches with the log and okay. Thanks.
So I don't even understand the question, the answer precisely, but yes, it is important, and you'll see that talk that they just did 1 hour ago, where they explain more nitty-gritty details on how it is implemented inside it. They are the true experts on signatures and so on. I am not. But what is interesting for me, what do you think from this experience? It's much better than PGP. That one, with that one, it will be a pleasure to sign it, and controlling it, we expect that it will be feasible. So honestly, the user experience, there is no key management. Authentication is like we do every day with email. I love it. That one, I want to use it. I don't want to sign with PGP anymore. On checking, yes, email is nice because when you can trust the email and you perfectly see it is my email. I still don't see precisely why would you trust my email for Maven, because it's my email. It's not something at Apache. So on that one, I don't know yet. I still need to figure out how we will do the verification in every detail. Clearly, the situation is way better than with PGP because it is human understandable. We still need to know how we will check with which tool and discovering which identities are to be trusted. But really, there is a huge progress with Sigstore on the signature on the checking side of the process. So definitely, we want to have it at Maven Central. Now it's a question of when will it be available, because I know that, yes, I want to sign. Can I do it now? You can. Nobody will know it, so nobody will be able to check it. So it's not yet fully ready. But as you can see from the demo, we have code, we have prototypes to sign exactly in full Java, the exact same thing that cosign does. Even cosign, it's experimental. It's not something that is yet completely finalized. It will be soon, but we can do it in Java. It works. So we signed a few artifacts. It works. We have a Java library at Sigstore level that implements reusable components to implement it, to later integrate it everywhere. So it works, it's very nice, job done. We have prototypes, it is something that is not only slideware. We will do it in Java, it will be nice. No, everything is online. I did not show you any file that is stored anywhere. We'll need to store the file on Maven Central to be able to know that an artifact that has been downloaded from Maven Central has been signed, the equivalent of the .ask file for PGP. We will need it. So working on that, we created a few prototypes where for each signed file we had one signature file, one check file, one record entry. We had 2 or 3 files for each file that is published to Maven Central. Then there is a bunch of additional files required by Maven Central. It was a mess. So we thought a little bit, how can we make it more sustainable for Maven Central? And this is something that, in fact, at Maven Central, we are not the only one who had the same question. PyPI has exactly the same question. NPM.js has the same question. How to store it in one file? Sorry, not a bunch of files. So this is why this question has been taken in charge by the Sigstore project, the Go one, the native one, and there is a work in progress to define the format of the file that will permit to check signature without contact record, without so offline checks like we do with PGP signatures. It is a work in progress. Last week it was promised to be done for this week. You know, we are in IT. In a few weeks it should be okay. So this format is really what we are waiting for to now implement it in Java. And so Apu will do it in Sigstore Java very fast, I'm confident. Then we will be able to test it, to continue prototyping, to continue playing with it from different actors' point of view, because we have Java experts, we have Maven experts, we have Gradle experts, we have Maven Central experts. Everybody needs to play a little bit to see how it will work in the future. And all that play will permit us to define what is the formal standard, what is the formal storage standards that we'll do on Maven Central for storing signature of our releases. Will we sign every file from the release? Will we sign, and you know that there are source jar, there is Javadoc jar. Will we sign each file separately? Will we sign the module? Will we sign globally the multi-module release in one in a row? That one we already know that we don't trust that it will be feasible. But will we sign each file or each module? Good question. We still don't know precisely. We'll need to figure out in the next weeks, in the next month. And one key question: should Maven Central use the famous centralized shared Sigstore server? Should we create our own? I don't know. Because yes, it is a question to be defined. So we'll need to define precisely. Now that we played with it for 6 months, we have many ideas. It has to be precise to define what do we want to implement in the next month. Then it will be about implementing it. And implementing means implement at Maven Central level, because currently PGP is required for every file. So when you will put to Maven Central your famous Sigstore signature file, the Sigstore signature file will have to be PGP signed. So you have a signature that is signed by another, yeah? Yeah, once we will know what is the official format that we will need to support. Honestly, a signature does not need another signature on top of it. So we'll remove that, and the next step will be, if you use Sigstore, don't require PGP. If you use PGP, don't require Sigstore. It's better to have an or than force everybody to use both Sigstore and PGP. So we will define when, how we will do that in the future. And that one is just for publishing to Maven Central. Then remember, what is important is checking. And checking, of course, Maven Central will check that that files are signed when ingesting new components. But what is important is that the developer downloading component will check. And this will be the work for the build tools. So we have in the community, we are working together with the Sigstore community. We have Maven developer, myself. We have, and Jason Van Zyl, we have multiple contributors. We have Gradle developers from the community, from Gradle Enterprise. Of course, this will have to be done by other build tools, whatever they are. They will benefit from the same libraries that we will reuse. And we'll need to define both a mechanism to sign and a mechanism to check. How? We'll need to define. We don't have precise plan at the moment. It is really something where the details will have to be defined once we have the format, once we have the greater plan. This is exactly what we are working on. I don't expect it will take much time once the format is defined, because we are all in. We are working together for more than 6 months. So once the plan is defined, we will implement it. It's not so much code, given we have the Java library that is available. So Sigstore at Maven Central is not yet a strict reality. You can sign, because everything will be on record, but nobody will check, so it's just for playing a little bit. You will have to wait for a few months, so the signature will be visible, will be published, and then you can work. And I'm looking for people interested to discuss about the checking, the signature checking tools, because it's something, and how to verify identities, because it is the key aspect that still needs to be refined, how we will trust identities for project. What question do you have? Yes, please. Yes.
So when you will receive an artifact, you will receive the certificate, the public certificate that has been used for signing it, and the signature, and then you will check that, okay, it's matching, right?
So the question is on the process to check. In fact, you will get the certificate and the signature. So from a technical point of view, you will check that the algorithm match. The key aspect of that, so technically from a code perspective, it will be nice. So you know now that the artifact has been signed by an email from an identity provider. The key question is, should I trust that email for that artifact?
You have the certificate.
I have the certificate, but I can, me as myself, create a certificate with my email, and why would you trust one email or the other? But technically, many people can sign the same artifact. So you will have one signature from someone who has an email, and the key question will be, how do you check that the email you have is really a contributor to the project, to the official project that you expect to have signed the binary? It is the key question. Will we go, and it has to be automated a little bit, because when you are downloading hundreds of artifacts, thousands in case of JavaScript, you won't do it by hand. So we'll need to figure out how to define who to trust on each certificate, because from a pure cryptographic point of view, it will be okay. It's not the question of cryptography. It's a question of trusting identities. Another question here.
What will be the workflow for CI/CD to sign?
So the question is, what is the expected workflow for CI/CD? The nice effect of using OpenID Connect is that I talked about email because I'm human. I didn't get to the details, but OpenID Connect supports machine workload authentication, so you will be able to sign with a workload identifier. And then we are back to the question, should I trust? No, a workload identity. So we are back to the exact same question of who should I trust when technically it is okay? Who should I trust? The time is over, so don't hesitate to discuss for the last question after the meeting. I hope you enjoyed it. Please provide me feedback and see you next year.